Today, let's talk about how to use a PASCO smart cart. First things first, whenever you write a lab report, please make sure it's all done on an 8.5 by 11 sheet of paper. Nothing too big, nothing too small. If it so happens to span multiple pages, then staple on the top left-hand side and ensure that all the pages are in order and nothing is upside down. If there's a graph, like in today's lab, the graph should fill up the entire sheet of paper. And I'll show you how to do it either in Excel or in Google Sheets. Answer everything in order. Please don't cram everything onto one sheet of paper. And if your pencil happens to bleed like this one here, write on one side only. As for the other requirements, follow along on page 13 for lab guidelines. As for the setup for this lab, have an incline. Incline should only be about one textbook tall. Place the cart at the top of the ramp, and please don't work alone. You need to have somebody beside you so that they're able to catch it and then return it back to you if you need to capture it a second time around. These things are pretty pricey. As for the software side on how to do it, there's a bunch of clicks that you need to do, but it might be easier for me to show you how to do this all real time. If you haven't downloaded the software already on your cell phone, then go on to the live one on the internet, sparkview.pasco.com. On the cell phone edition, just ignore the first 3 clicks. You can click on no for the GPS location, but the 4th click, make sure you click on yes, otherwise it'll never detect your device. Regardless of what platform you use, click on sensor data, click on the Bluetooth icon, which is on the top right hand side for most platforms, and on cell phones I believe it's on the top left hand side, and select your corresponding device. Now you have to turn on the device first for it to find it, and when you click on this, just make sure you click on yours serial number, the one that's listed right up here. Otherwise, you might be capturing data which is your classmates, not yours. The default settings here are perfectly fine. You can just click on graph, and you're just about ready to go. Now, due to timing errors of human beings, it's very difficult to click on start and let the cart accelerate from rest right from the beginning, so you'll want to do some automation. On the bottom left-hand side, these are your sampling options: periodic, common sampling rate. 10 Hertz is more than enough for us, and we want this to start capturing data when the position is above, not rises above, but is above 0.001 meters. In other words, the moment it's moved an inch or a millimeter, then start capturing the information. And you probably want it to stop for you afterwards as well. And since for our lab we only need the first, time-based, the first 1.5 seconds of data, or 1.4 seconds worth of data, then it'll be time-based and stop after 1.4 seconds. You're just about ready to go. Look at the arrow on your smart card. This is the direction that it will go down towards. Place it at the top of your ramp, and then with this 0 sensor over here, or the tare, click on it so that the position sensor goes to 0. And you'll notice that when I click on the start button now, it won't capture anything until you let go of the cart. Again, make sure somebody's on the other side to grab it. And if you're not using the cart at that very moment, then make sure that it's upside down. And yeah, watch out for the spring. It can catch you at any moment. So keep it upside down so it doesn't roll and fall off the table. But if you're doing the lab, then place it right side up. I know it's tempting to click on this button over here and call it a day, but you'll notice that the graph here, its resolution is fairly low. It's lacking all the minor grid division lines. Unfortunately, there's nothing you can do within this software platform, so you need to export it all. So you'll click on the hamburger button on top and export the data. Oh, maybe I should mention this first. Let's say that your first capture isn't as good as this. Let's say that your first capture is something wonky like this, and you want to get rid of it because now you have multiple data. Well, you'll want to click on the toolbar icon over here, and then you can manage runs, and it was my last run that was bad, but you can also choose which one specifically to get rid of. In our case, run number 2. I didn't like that, and now I have just one set of clean data to export. Click on export data, save it to wherever you need to save it to, and let me show you how to use software. So let's say you happen to use Excel. You can click on open and open up the most recent file. I'm just going to drag and drop it in. And yes, convert all the data here. The first column you don't need, so you can select it by clicking on letter A on the top column, right mouse click, delete, and that'll delete the entire column for you. We don't need the rest of this data over here from force to acceleration, so we can also right mouse click and delete. Same as the remaining information. Now, if you know how to use your keyboard as well, then yes, you can hold down Shift while you select the rest of them, right mouse click, delete. And now our data is mostly clean. We have a few messy things over here, so we can also click on rows 2 and 3, right mouse click, delete. And this might give you problems later on, so you might want to say that the initial time is at 0. And we're just about ready to go. Select all that data, insert. What type of graph are we looking for? Scatter chart. And if you want to include the dots, then by all means. But I mostly prefer this one right over here. You want to ensure that this is on its own page so that it prints out properly. So you click on Move Chart to the location of a brand new sheet. You'll notice that this graph over here is missing labels in both the vertical axis and the horizontal axis, so you can add them in. Add axis titles. Give an appropriate title. We don't need units for our title, just simply state that this is a position versus time graph. I notice that I am on group number 2, so you want to state that for group 2, no added mass. For your other group, you may want to add a mass on top before you conduct your lab, and this time around be extra careful. Catch it before it hits the bottom of the ramp. Okay, otherwise it might make a dent on the wheels themselves. On the dependent axis, this is a measurement of position, measured in meters. And on the independent axis, this is a measurement of time, measured in seconds. All right, let's continue with our formatting. As mentioned, we want to activate minor grid division lines. So you'll select any number on the axis and right mouse click, add minor lines. I notice that my data on my horizontal axis looks rather messy, so I can just double click on it and start fixing this up. I want my boundary to be between 0 and I only need the first 1.4 seconds of data. And with the increments on my major axis, that looks pretty messy. I probably want to increment it in tenths of a second and let my minor grid division lines be, 0.02 seems quite all right. In fact, I forgot to activate this as well. Add minor lines, and that looks good. Now my numbering over here doesn't look so pretty, so I probably want to change my numbering from scientific to general numbering, and that cleans it up quite a bit. And really, that is the name of the game whenever you're producing graphs. You want it to be very easy to read and the numbers easy to interpret. You don't have to label every single graph line. You can skip a few, and as you can see over here, it's been skipped in such a clean way that you can quickly interpret that this point over here probably represents 1/5 of this value over here. So that represents 0.02 seconds, 0.04, 0.06, 0.08, and 0.1 second. And you want the same treatment on the vertical axis as well. The data should fill the majority of the sheet, so if you're scaling over here, crams it too much, then spread it out. As for the overall layout, it would be best if the entire graph was a perfect square, but you do your best when it's mostly automated in the software. I'm sure if you use a regular graph paper, which is totally acceptable on the lab, then everything's all perfectly as a square. As afterwards, you'll need to draw tangents, and it's messy drawing tangents when you have rectangular dimensions. Okay, make sure that they're nice and square for the major and minor ones, and that way it's quick and easy to read what the values are when you draw your tangents. And that's pretty much the setup if you so happen to use Excel. If you use Google Sheets, well, that's a little bit messier, but we'll go through that anyways. So under sheets.google.com, you'll want to start a new spreadsheet, and you'll want to import the data. Import. Where I'm going to upload it, and I'm going to drag and drop that into here. Just like in Excel, some of these columns are unnecessary, like the first one over here. So you can right mouse click on it, delete column. Same as the force all the way up to acceleration. So you can hold on to the shift key on your keyboard, select from B to F, right mouse click, delete these columns. And the last remaining columns we don't need either. So we can select them all and delete them. If you have weird data like this, like how I do, you can select columns 2 and 3, right mouse click, delete those, and just to ensure that no funny business happens, this is effectively 0. There's a bit of floating point error in the data that's collected, and that's fine. Okay, now with our raw data all cleaned up, we can now start plotting it out. Scatter chart is what you need, but if you still happen to want it to be connected, then by all means activate that connection there. The printout won't look good like this, so you want to shift this onto a sheet of its own. So move to own sheet, and just like with this software over here, the resolution of the graph isn't so good, so let's improve that. Nope, you don't click here. What is it this time around? Edit the chart, customize, and we want to activate all the minor grid division lines. So yeah, you'll go into edit the chart, customize, grid lines and ticks. For the vertical axis, we want to activate minor grid division lines. And you probably want to do the same thing with the horizontal axis as well. Sometimes automatic isn't so good, because if you look at the divisions of this represents 0.033333 meters, and this one would represent 0.0666, and that doesn't seem to make any sense. So you want to have your minor counts in very easy to read divisions. Now you could divide it like this. Let me just show you for the vertical axis. You could have your minor count set to 1, so this would represent 0.05 meters. But to increase the resolution of this graph, for if you have more lines, that means that you have more precision in your measurements. And that greater precision results in greater accuracy as well. Okay, so 1 division, it's okay. I've noticed that if you use 4, it's a lot better, because this represents 0.02, 0.04, 0.06, 0.08, and now 0.1 meters. And if you need more, then by all means use 9, that's fine. You don't want to use 10, because that makes it confusing again, because that means that you have to now divide this 11 ways. And now you're going to have decimal values of, what is this, 0.0999 or something like that. Yeah, don't do that. Just keep it with that and you're good to go. Let's fix up the horizontal axis as well. We probably want to have divisions of, yeah, that looks okay. I mean, the closer it is to a square, the better. Maybe we want to clean up the vertical axis to 4 as well. Yeah, I think that's about as good as you can get with this one here. And you will notice that on the horizontal axis, it still looks a little bit messier. So you want to change the scaling of this to just general. Where's general? None? Yeah, none. That gets it done. Still, the scaling of this looks messy, so you'll want to look around for... oh, no. Is it scale factor? Nope. Right here. Okay, for the horizontal axis, we probably want to have a major step value of increments of every 1/10 of a second, and that cleans it up quite a bit. And I guess we're going to go back to the vertical axis and fiddle around with that so that, hey, we're back to squares again. And I guess the last thing is to make sure that that the labels are correct. So the chart title should be position versus time for group number 2, in our case over here, with no added mass. Our independent axis is time measured just in seconds. Keep it nice and clean. And for our vertical axis, just position in meters, and that's fine. When you're ready to print this, you don't want to be clicking on download chart into a PDF document, because you can try this out. It looks really messy. It's all chunky, all the grid division lines, and it won't look well nicely when you print it out. Instead, when you print it out, you'll want to go to File, Print, or Control P. And if you print it out, and from this setup over here, it looks a whole lot cleaner. Even if you still happen to convert it into a PDF, it's going to look like a much better graph. I'll open it up right now. See, it's a lot cleaner than it would have been if you used the built-in one. All right, and that's pretty much the general setup on how to use one of these fun little things. Have fun with that, and I'll see you tomorrow.